Hello, hello. It's us
Well,
again.
it's us again, and you again. Thanks for being here. Welcome to You Choose, a choose your own adventure style show through the CNCF landscape. We're in chapter 4 and already at episode 7. And today we're going to cover cloud cost.
Exactly.
I have something to say.
Say it.
I'll get corrected probably later in the episode. But
Just
I
say
have
it.
to say,
Don't.
the job of a salesperson for a cost solution company seems like a pretty easy job. Because it's like, hey, do I save more money than it costs to install the software? Yes. Okay, great. Buy it, you know? What do I have
Exactly.
wrong? What am I missing?
No, that's the pitch as far as I understand it. We might be correct. We might get corrected later. Yes, but it's a very it's a easy sell. I mean, it's a tempting thing, right? Who doesn't want to save money?
And I guess there's also, and we're kind of jumping ahead because we still need to talk about last week, but there's also there's a time investment and there's a learning investment that goes along with the just simply saving money, I'm sure. But
Then I heard saving money, and everything else you said after that is gone.
I'm in. Sell me some more. Let me save some more money. The more I buy, the more I save. Okay, but let's talk about last week. Last week we discussed progressive delivery, which is about rolling out applications at a slow and gradual pace and testing all along the way to make it sure it's safe before rolling it out even further. So the idea is stability and security as part of your application delivery, yeah?
Yeah, expose it to a subset of your users. Verify whether it's okay, and by verify I mean do whatever you would do in Grafana or whatever you're using to observe your system, right? Do that, observe how it's behaving, and if it looks like it's going okay, then increase the reach to more users and repeat until it's rolled out fully.
So then our contestants were Argo rollouts and Flagger. Why are the GitOps? Argo and Flux I associate with GitOps. Why are but now they do progressive delivery too. Why are those kind of together?
Yeah, Argo is a group of projects. It's not the name of any single project, right? So actually, I believe that Argo Workflows was called Argo initially. I believe. I'm not sure about that. At least when you install Argo Workflows, the namespace is called Argo. So, but yeah, Argo is a group of projects, and then there is CD, Workflows, events, and rollouts. And similar thing is happening with Flagger, right? It's a part of the family of projects. And by projects in this case, I mean two. That would be Flagger and
that's
Flux.
what I thought.
Siblings.
They're siblings, they have more than one thing umbrella under these Argo and Flux bigger brands because everything has to do with application delivery. Everything has to do with deployment. Is that right?
I mean, I like to say synchronization of resources defined in Git into your Kubernetes cluster.
Okay.
Whether that's deployment or application or something else, it's questionable. Okay.
So the problem in Kubernetes is that you still can kind of do rollouts, but it's pretty coarse grained. It depends on how many pods you have running. One pod up, one pod down. And so you can't control the speed of it very much. And you can't, like you just said, do the checks to make sure things are healthy to tell it to keep moving.
Not
or
good
to
ones.
Go backwards. Yeah. And there's no automatic failure recovery. With these
there is
tools
no
that we
rollback.
talked about. No rollback, yeah. You can roll back. You just have to do it manually. There's no
you can do everything
failure.
manually.
There's no failure detection and automatic rollback, right? Yeah.
I mean, you can manually do progressive delivery as well. You can just use Kubernetes deployment, put it to one replica, and then see whether it's working. Then put it to 2 replicas manually, and then see whether it's working, and so on and so forth, right? Everything that rollouts, Argo rollouts, and Flagger do, you can do without them manually. But you would be a fool to do so.
So, and these tools rely on other tools too. Like you need to have networking like a networking tool in place, don't you? And you need to have an observability tool in place before you can do progressive delivery. Is that true? No,
you don't have to. So you can do progressive delivery by saying, hey, roll out to 10% of my users and pause indefinitely while I do whatever I'm going to do to validate it. And then you go back to the command line and say, continue.
Okay.
Right? So you can do it without any metrics like Prometheus. And you can do it also without, I mean, networking you need to have independently of those tools. You need some ingress. It doesn't have to be service mesh. So ingress or service mesh. So you can do it. I think that you can do it even without ingress or service mesh. It's just that I repeat the same sentence as before. You would be fool to do so.
That was going to be my next question. Would there be any reason to do it without those things? So rollouts, progressive delivery tools are building upon good practices that you've already put into place.
Yes.
Are they related at all to GitOps? Do you have to have GitOps?
No, you don't have to have GitOps. You can actually, I don't know, today I'm going to do it with Argo CD, but you don't have to. They're independent of each other. Now, in case of rollouts, you can get some additional benefits of using Argo CD, but it's fully standalone, really.
Okay. And I understood that like each one is optimized to work with its particular GitOps tool, but they could, if for some reason you wanted to use Flagger with Argo CD and Flux with Argo rollouts,
no problem,
you
really.
could.
The only difference that you would see a few additional things in Argo CD if you do Argo rollouts. But you can do it without Argo CD or with Flagger or with Flux. It's all good. They're standalone projects.
I have a question. This is a preference of yours. If you had to choose between rollouts and GitOps, what would you choose? Progressive delivery and GitOps. Yeah, you can't do both. Which one do you choose?
GitOps.
GitOps. Really? Why?
Yeah.
That was so
because
easy for you.
it's so easy and basic and reliable. I cannot imagine a reason why somebody wouldn't. You assuming that somebody is using Kubernetes. Progressive delivery is tricky, really. How much do you trust yourself to define what good means? It's a tricky one.
Yeah, and the tools can't help you with that. Or maybe they can. No. So then what differentiates the two tools from each other? Argo, rollouts, and... Uh-oh, you're making a face. And Flagger.
Nothing important.
Nothing important. It's what the guest said is the implementation of what actually happens under the hood is totally different.
Of course, but from the user perspective, I stand by my declaration of nothing important. They're both good. There are a few things like, for example, Flagger can run load testing, generate traffic if you want to do progressive delivery outside production. But again, not that it matters that much.
I can't think of another example where two completely different implementations are so evenly matched.
I can give you one example.
OPA and Kyverno?
No. Argo CD and Flagger.
And Flux?
Flux, sorry. I mean, if you exclude the UI, which I believe that Flux now might have, if you exclude the UI, they're basically doing the same thing in a different way. Different things happening behind the hood, and different way how to define what you want, but essentially conceptually the same.
With the same result. Fascinating.
Yeah.
It's like if humans like evolved some other place too, and then we come together. Anyway.
Okay.
Who won? Who, excuse me, got chosen?
Oh yeah, who won? I have it somewhere. Wait, I don't know where.
I got it. There
There we go. There we go. Oh, there we go. Argo rollouts won. So
Argo
let me
rollouts.
put it on a screen and let's do it. Let me show you how it works. Remove the. Okay, cool. So here I have definition of something that in Argo rollouts is called analysis template, right? So basically, this is a analysis that will be executed when I start doing it, when I start rolling it out. It could be inside of a definition of rollouts itself or outside. Outside is nicer because then you can reuse the same thing. And the short version of it is that I'm saying, hey, if the result of whatever I'm going to do is more than 90%, it's okay, right? So if it's 5% or more of other result, then it's not, right? And the result is this query. And this query, I'm not going to deep into it. Basically what it says, hey, find me, summarize the rate of all the requests for this application. There we go. For this application, whatever the application is, and only if there are not 500 or 400 responses, right? So give me the sum of all requests that were okay, in other words. And then divide that with sum of all requests. And basically what you get when you do that calculation, you get the percentage of requests that are cool, okay, right? Not failing. And that's that. If that outcome is 95% or more, we're doing great. If there are more than 5% of failures, we are not, right? Relatively easy, straightforward. I mean, the queries in Prometheus are never easy and straightforward, but trust me, that's what it does. So I'm going to add push commit over there. I'm going to switch to Argo. What you don't see, I'm going to refresh Argo CD so that it hopefully does that. Oh, come on. Production infra, come on.
Are we meant to see Argo CD right now?
Yeah, we are meant to. Okay, yeah. I was hiding it because I thought it's not important, but okay. Now I pushed the right thing. Here is Argo CD. Let me make it bigger. There we go. And refresh, and the analysis template appeared over there somewhere. Cool. Okay, so we have the template in our cluster. Everything is going great. I'm going to use YTT now. What you see on the screen me doing now is not something that I should have done in advance. It's a setup. It doesn't matter. What does matter is, okay, this is also setup. Ignore me doing this. Okay, so I'm going to generate manifests of my application, right? And I'm using YTT because that's what people chose in one of the earlier episodes. And here, what I'm doing is typical stuff. The things that matter is that I'm creating virtual services because I'm using Istio today. And those virtual services by default are going to send all traffic to the primary, to the main release, and no traffic to the Canary release, to what I'm going to release now. And the other thing that matters, if I find it, no, database, no, I don't care, ingress, I don't care, gateway, I don't care, what I care is somewhere, service, deployment, no, I'll find it, I promise. It's, okay, here we go. This is the rollout definition that essentially, let me see. Essentially, I'm saying use the success rate, use the analyzer that I defined earlier. Start analyzing from step number 2. You'll see what that step is. And here are the steps. And here I'm saying, hey, you know what? Increase the reach of the new release to 20%. And then wait for a minute. And then analysis starts, because I said that it should start from the second step. And from there on, I'm increasing to 40, 60, 80%. And in between each of those increases of the reach of the new release, there is a pause. And during that pause, it will be analyzing what's happening in a cluster and decide whether to move forward or go back, right? Okay, now I'm going to push that to Git as well. Here we go. And I'm going to, Argo CD should soon synchronize it. And if it does, we should see, let's do this. We should see it being rolled out. Not yet. Not yet. Why? Okay, let's see in Argo CD. Am I synchronizing the right one? Yes. Okay, now it's working. There we go. Now I should see the rollouts being rolled out. No. Come on. There we go. And the first release goes immediately, goes fast right away, right? Because there is nothing to roll out progressively if there is only one release of the application, right?
Yep.
No need to wait for anything. So what we are going to do is start simulating that this is production. I'm going to do load testing. I will be bombing my application with requests to simulate as if this is a production.
Cool.
And I'm going to create a new release. And I'm going to do that by saying, you know what? Change the tag of the image to 2002, right? Generate the manifest with YTT. There we go. And basically same application, just a new tag, and push it to Git. And then we're going to watch what is happening. Actually, in this terminal, I'm going to be sending requests as well so that you see what's going on. Right now, you can see that you see the number here, 001. You see from which release it's coming, right? And we're going to see what Argo Rollouts is doing right now. Okay, you see here at the top here, it is running it is setting it up, right? And approximately 20% of requests are going to the new release. And if you follow what's happening down here, you will see that 1 out of 5, more or less, are saying release 02, right? So right now, 20% of my users can see the new release, and Argo Rollouts is testing it. It's not testing it yet. It will start testing it on a second step. And that will happen 1 minute later. So now it's 46 seconds. It will soon increase the reach of the new release to 40%.
40%.
Mm-hmm.
We have a question
And
about...
it will...
Yeah. Why use a cluster? Does it have to be cluster namespace? Can it be namespace scoped?
Yeah, it can be namespaced as well.
Okay.
It can be namespaced. I was too lazy to... Cluster was easier for me. But so far you can see that it is successful, right? So this is analysis. I have only one query, and it's so far so good. And it will continue analyzing it. And if it fails, if we have time, I will show that later what happens if it fails. But so far, so good. Right corner, you will see now gradually the responses from 002 will be increasing until it reaches 100%.
So
right?
Do you want to leave this on the screen while we start talking about costs stuff?
Yeah, let's exactly. Let's talk about cost, and then we get back for a very quick. Let me show you how to fail. What happens if it fails?
Okay, but we'll leave this on the screen for now. Yeah.
Yes.
Okay. So what? So we're
we are talking about it's on a screen. Okay, got it now. Yes.
Yeah. So we're
go for
talking
it.
about cloud cost tools today. And what do cloud cost tools even do? Like, I understand they help make it cheaper to run, help you like optimize your cloud cost, but what does that mean in practice?
I will probably be hanged by our guests for what I'm about to say. Be ready for it. I don't think it's about cost. I think it's misleading. I think that cost reduction is a side effect of something else. And that something else is resource optimization.
Yeah, that's what I was wondering about too. Yeah.
Right? So the real goal here is to make sure that our applications are using just the right amount of memory and CPU, not more because that costs more, not less because then they misbehave. And it's about using the right size of nodes and the right number of nodes in our cluster. Again, because if we have more capacity than what our applications need, we are paying more. If we have less capacity, we are suffering, right? I feel that that's the main objective, right?
That's what I thought too. But then I think there's also a component. I understand that like it can plug into your cloud provider's API, and if like Google Cloud is all of a sudden way cheaper than AWS, then it can move over. Like, does it actually do something can it do the right sizing? Can it do the optimizations for you? That's what.
Can it do? We're gonna hear from the guests. It can or can't. We'll see. But yeah, you can definitely optimize your resource usage so that it's cheaper, right? There is a secondary goal is that if you're gonna be billing internally, you want to have that information as well, right? So you want to know, okay, so if I'm sending bills to different teams in my organization, departments, I want to know how much they spent so that I can charge them and put whatever is the overhead, what's or not, right? So it's not really exclusive about resource optimization, but I feel that that's the main goal.
Resource optimization, maybe switching around to always have the best price. Maybe we're actually watching price in real time. And then like understanding what each team is doing from a cloud perspective. And I would go a step further, Victor, and say that not just like what workload containers it's running, but also what services and how much load and how much network it's using. Like I wonder if it goes deeper or if it's more at that application container level.
It can go as deep as you want, right? Containers, servers, cloud resources. It can, in theory at least, especially if you're talking about cloud. I mean, when we're talking about on-prem, it's a slightly different story, but at least on cloud, you can optimize or resource usage, whatever those resources are, right? Resources are not only containers. It could be lambdas.
Yeah.
Databases. It can be many different things.
That's, And then I'm wondering if it automatically optimizes that stuff for you or if it like, gives you a printout of what you should do to be optimized and you have to go in and manually do it. That's a question I have.
Yeah. So whether it's automatic or manual, that's now to be seen.
Yeah. And then another question. I had another question. Oh, did I just lose it? What does this have to do with observability? Like, I get that it's like, are we actually using metrics and logs and traces and stuff that we talked about before, or is this just a different ballgame?
I mean, it is observability in two different. First of all, it is observability because to make decisions, or to inform you what to use or what to do, you need to know how much memory is consumed, how much CPU is consumed, how much disk is consumed, how much network traffic we are making, and so on and so forth, right? You need that information, which is typically available as metrics. Now, whether you are collecting those metrics already or no, that's a separate question. And whether those tools should use the existing metrics you have or generate their own, again, separate conversation, but you need metrics one way or another, right? And probably you're going to combine that with some other data that is not necessarily something you're already collecting, like prices from AWS, Google Cloud, what's not.
Yeah. So we're talking about, in the end, it's a return on investment equation, kind of like we were talking about at the top of the episode. But it's not just like how much the software costs versus how much I save. There's also a time investment. There's also what kind of footprint does the tool have? Like what kind of full footprint does all the metrics that are collected have? Am I collecting more or using what I already have available? That sort of thing. So there's a lot of hidden cost in I imagine in these tools too. But Victor, bring us. Yeah, talk about the demo.
I was now distracted. I'm not sure what I'm doing right now. I think that I was supposed to deploy release 0.3 but it seems that I deployed O2, O1. So I think that I rolled forward by rolling back. So right now, no, I'm not watching it anymore, actually. Yeah, I think that I don't know what's going on. But okay, so it successfully rolled out to the second release, and I was supposed to show you how it should roll out to the third, but I failed somehow. Trust me, it works if I'm not too distracted by Whitney.
I take all the blame.
Of course.
It's a riveting conversation about cloud costs. All right, with that, let's bring some experts on to actually talk about what we're making guesses about. So let's start with Matt Ray. Matt, will you introduce yourself, please?
Hi, everybody. My name is Matt Ray. I'm the former community manager for OpenCost. I recently changed roles, so I'm now listed as the maintainer emeritus, among others, but I'm happy to still talk about OpenCost.
Awesome. Thank you so much for coming and talking about OpenCost, even though your life has moved on. I appreciate you sharing your time and expertise. Yep. We'll see you very shortly for your presentation.
By the way, this is a good segue into, I just realized why my demo is failing.
Okay.
It turns out that I'm running more pods that require more memory than what my cluster has. So the new release is in a pending state.
Oh, okay.
It's a good segue into what we're going to talk now.
Awesome. Thank you, Matt. Okay, next up we have Yasmine. Yasmine, welcome.
Hello, thanks for having me. My name's Yasmine. I run product here at StormForge and been doing the infrastructure automation space for quite a while now. Before this, I was at Puppet, and then before that, I was an SRE. So kind of living a life as the industry kind of changes and now everything's Kubernetes focused.
Right on. Is there anything that Victor and I got totally wrong when we were talking about?
Not totally wrong. What I love that you said is that it's about resource optimization, because that's how we kind of view it. Cost is a byproduct of that. And then the one thing maybe slightly wrong is that, everyone wants to save money. It should just be so easy. I think the hard part is when you get developers involved and they're like, I don't want you to change my machines. I don't want you to touch anything. So
not everyone wants to save money. That's an assumption that we made.
We'll talk about that. Yeah, of course.
Excellent. Thank you. All right. So last but not least, Phil, hello. Will you introduce yourself, please?
Sure. Hi, I'm Phil Andrews. I'm field CTO here at castai. I've been here a little over 3 years now, basically since the initial product market fit for castai. Previously, I was director of engineering at Oracle Cloud in the security products division. So I ran about a 50-person engineering team across 3 different Oracle products. So that was kind of my background before coming into the salesy type space. So I'm more of an engineer than a salesperson. So bear with me. And one thing, Victor, if you had been using castai, we would have auto scaled your cluster for you, and you wouldn't have had a pending pod.
Right.
The problem is that we are not introducing things that haven't been explored yet. So starting from the next episode, it will have a cluster scaler. Yes.
Thank you, Phil. We'll see you shortly for your presentation. Sometimes we try to skate by without addressing this, but we got called out. Is StormForge an open source project? So right now, the only open source project we're using today is OpenCost that Matt Ray is representing. We brought the other ones on just because this show's a lot more fun if we have a conversation. But in general, if we have the opportunity to keep it all open source and more specifically all CNCF, that's how we try to scope this show. But when there's only one project, we get to play. So here we are. All right, Matt, we're going to bring you on, and Victor's going to tell you when to start. Or just start while he's distracted and get yourself a few extra seconds.
It will happen. It will happen.
You're too good, Matt Ray.
I'm ready.
No, you can. If you were more experienced, you would have started before I said go.
All right, I'm
go.
starting. Okay, so OpenCost.
Go.
OpenCost is a CNCF project. So yes, we are open source. It is about 2.5 years old now. But it started as the billing engine for the KubeCost commercial product, and they open sourced it through the CNCF. And it's continued to expand and grow and pick up other users and maintainers from other companies. And so it is both a specification and an implementation. So the specification explains how Kubernetes costs are monitored how you allocate what costs belong to CPU, to RAM, to storage, and so on, how those costs get split up. And it is currently a CNCF sandbox project, but voting is happening right now to move it into incubation. So fingers crossed, you'll have something to talk about in Salt Lake City. It's also a certified FinOps solution. So the FinOps Foundation, which is a sub-foundation of the Linux Foundation related to cost management in the cloud, it's a certified solution for them. And that just means that we're providing part of the big picture for how to manage the cost of all your infrastructure. The website's there. The code is on GitHub. And we're, of course, we're listed on the CNCF landscape. But a few quick things about the project. The specification, it's key to understand how costs are monitored, because a lot of times these workloads are transient. They might vary in how much resources they consume at any given time, as well as, they might not be here in 20 minutes, or, they might be coming and going. So the OpenCost specification kind of nails down how that gets recorded. We went through a lot of other companies and organizations worked on this, Red Hat, SUSE, AWS, GCP, KubeCost. And so they all kind of came together and talked out how we're going to record this information. And then when you're using OpenCost, if you're monitoring Kubernetes costs, what gets measured: CPU, memory, GPU, storage, and load balancers. And then we allow you to slice and dice that data any way you want. So pretty much every primitive inside of Kubernetes is represented, whether it's a deployment or a service, nodes, clusters. We allow you to view that data, and all of that is available however you want. In addition to Kubernetes, OpenCost recently expanded their footprint. So they introduced cloud costs earlier in the year. And so this means rather than just Kubernetes cost, it now has access to your full AWS, Azure, GCP, Alibaba, Oracle, the full billing data. And there's not actually a lot of other open source projects out there that give you this access. We put it behind an API so you can run reports against it and queries into it. And that's also exposed in the UI. And then carbon costs and plugins were recently introduced maybe 3 or 4 months ago. Those are still under development, but they are exposed in the API. And so, and there's a plugin architecture so you can bring in new cost sources. So the reference example was Datadog. So you can now pull your Datadog billing in and explore that bill behind an API and Prometheus, and then push it into wherever you want. And carbon costs, we're going to put that right next to the cost of your Kubernetes workloads. So you can see how much a namespace costs by its carbon footprint, which is pretty exciting. So if you're running OpenCost, it is pretty simple deployment. We have a Helm chart, of course. You can also, it deploys on top of Prometheus. So we use Prometheus as both our data store, and we also expose OpenCost as a Prometheus metrics exporter. So you can scrape OpenCost directly. We store the data in Prometheus. You can pull whatever you want out of Prometheus. You can push it to, Thanos, Cortex, Mimir, or Victoria Metrics, as well as, you can pull it via the APIs or do exports with our Parquet exporter into other databases and tools as necessary. And then if you don't want Kubernetes costs, you can run it in Docker and just use it as a API and reports for your cloud costs. And then you don't even have to run Prometheus. You can run it as a pure metrics exporter if you really want to. It has a UI. The UI needs work. If you're an open source Node.js developer, we would love to get some help.
You're done.
I'm done.
You're
All
done.
the data's available.
Oh, I forgot the gong. Wait.
URL. Nailed it.
Thank you so much. That was wonderful. Appreciate you, and we'll see you soon for the questions part. Which, speaking of, if you have any questions, please post them in the chat, and we will have a Q&A part of this show and answer your questions. And so, meanwhile, it's time for the next presentation. Yasmine, go ahead and get started, please.
All right, I'll try and
Go.
go fast. So OptimizeLive is a continuous right-sizing tool. We give you recommendations for requests and limits on all of your workloads, and then we automatically go out and patch your workloads so that we can deploy those recommendations. Our agent gets deployed inside your cluster. We support any Kubernetes distribution. We support all Kubernetes workload types, so like deployments, daemon sets, stateful sets, batch jobs, cron jobs. You list them, we support them. And that agent is deployed read-only to start with so that we can collect the metrics. And the metrics we collect is like usage on CPU, memory, the HPA, that sort of thing. Within a couple minutes, we start to give you recommendations, and we're analyzing that impact behind the scenes. We use machine learning to do that. And when we give you the recommendations, they get better over time. So for example, after a few days, we feel pretty confident with the recommendations, but say we have a few weeks or like a couple months of data, we can start to detect seasonal trends in that forecast. For example, on the weekends, you need less resources. During the week, maybe 9 a.m. on a Monday, you need more resources. So we can detect those trends and then give you the recommendations for what works. And we are right sizing. So typically, because there's a lot of waste out there, we right size down and find cost savings. But also, if we find resources that don't have enough resources, then we will obviously address those as well. I'm just going to jump into a demo pretty quick. We aggregate all of that data that comes into our UI, and we show that to you at an estate view. We show it at a cluster view or a namespace view. If you have thousands of clusters, we'll show that here. If you have just a couple clusters like we have in this demo, we'll show that as well. And I mentioned the agent is read-only to start. When you want to actually apply these recommendations, you can do that by hitting the apply button. If you have the applier installed in the UI, you can download the patch from the UI or the CLI, or you can have us automatically deploy that for you. And that's typically the approach people take. And also at KubeCon, we'll be announcing support for our admission webhook as well. One of the things that our machine learning will do, and Victor, you're smiling, you requested this last time, so we want to make sure this KubeCon we had it. One of the things our machine learning will do is if you have a HPA, it will detect that. And as you can see here, the impact, the purple line is your current total requests, and then orange is what our recommendation is. And then if we detect that HPA, we will also give you a recommendation for the target utilization. We want to just work with all the tools in the ecosystem. So if you're using the HPA, we support that. If you're using CADA, we support that as well. If anyone's kind of tried the VPA out there, there's a thrashing cycle. So the HPA sees your sees your target utilization, and if you start to go above that, it'll give you more replicas. The VPA will come down and bring you down, right size it, and then you go into that thrashing cycle. So our machine learning will watch that and then give you a patch for both the deployment and then a patch for the HPA as well. And we'll support any sort of whether you're scaling on CPU, memory, custom metric, again, CADA, any of those. And then you asked why aren't people just doing this? A big part of the challenge we see is not everybody is incentivized to cut costs. So developers want to just deploy, and they don't want to be called in the middle of the night. So they will give their workloads more resources. And so we think it's important to give people as much input into the recommendations as possible so they have that confidence to deploy it. So whether that's choosing the schedule it gets deployed on, so like daily, weekly, Tuesday nights at 11 p.m., or when they're deploying these recommendations, allowing them to set thresholds. So don't deploy a recommendation unless it's at least 10% greater than the last one. Or if I have a really large recommendation, deploy that over time. We also so for example, a common thing developers will do is say, I want to actually be more aggressive in non-prod, but in production, especially on the memory side, I want you to take the reliability side. So we let them kind of have all that input into what is your optimization goal? Is it about cost savings, resource savings, or a balance of the two? And then something that is often talked about is more a religious debate, how you treat limits, especially on CPU, also impacts your costs because how you set your optimization policies will make an impact. And we know everybody is going to have a different opinion. So by default, we'll optimize your requests and we'll only increase limits if needed. We'll never decrease them. But you have the flexibility to say, no, I actually want you to optimize requests and limits, or only optimize requests, or set a custom limit request ratio. So for example, for memory, you can say your requests always equal your limits. I think a lot of when it comes down to cost optimization, the thing that holds people back is that confidence that the changes won't impact their machines. We hear this also on like Java workloads. How can I optimize Java workloads for cost without time?
Time. I'm forgetting. I'm listening for a change, so I forget about the timer. Yeah.
Oh, I love the gong, Victor.
I know. I'm going. Okay, I promise. I'll stop. I won't listen to the next one and focus on the timer.
Thank you so much, Yasmine. All right, Phil, do you hear that? He's not going to listen to you.
Oh,
That means you
that's not
should
bad.
just hurry up and start before he starts the time.
All right, so here we go. So castai is, to Victor's earlier point, a resource optimization platform around Kubernetes, right? The goal is resource optimization. Cost optimization is a side effect of that, and a great side effect of that. Castai does work across the three big clouds, GCP, AWS, and Azure, as a full autoscaler, the full platform. We also support a subset of our features on the non-big clouds. So in this case, you can see up here, I've got an Anthos cluster that I've been running on. Some of our feature set does work on basically cloud agnostic. So I'm going to jump into kind of what castai does. The core piece of what castai started as when it was a beginning project company 5 years ago is a cost-aware autoscaler. Being able to autoscale with the most cost-effective instance types possible. AWS has 700 different instance types that we would consider production viable. If you're in a 5AZ region, that's 3,500 different spot prices and 700 different on-demand prices. No developer out there is going to go through 4,200 different pricing options and choose the most cost-effective one for their company. They don't care that much, right? They're going to pick one that's good enough. It's likely going to be an M6A, maybe an M7A, maybe an M5, something along those lines, and they're going to move on with their lives. Castai is evaluating every single time the cluster needs to scale up, what's the most cost-effective way to add capacity. You can see in this example, we've got C3 high CPUs. This is a GCP. This is a spot-heavy cluster. We have customers that are full spot. We have customers that are full on-demand. I would say most customers are hybrid. You can see we've got a lot of different instance types here. The resource allocation on these, 100% requested to provisioned. These are fully utilized machines on the CPU side of things. Memory, less so, but memory is 1/10 the cost of CPU. You want to optimize on CPU first. If we take a look at the total cluster, this cluster is running at 95% provisioned to requested capacity. There's 5% waste in this cluster. The industry average is 56%. 56% requested to provisioned. That's what castai does. That's why it's important to not only have the workload right sizing and the cost monitoring, but also be able to actually manage the cluster and be able to automate the management of the cluster. This is a real example of a customer that we onboarded a few months ago. This is castai, right? They started at $55 a day on this dev cluster. By the time we got them tuned up, they were at $9 a day. This is where the cost comes from. They chose to move to spot instances because it was development. They had aggressive cost-saving goals. castai migrated them over seamlessly. They have had 0 service interruptions in 4 months that we've been working with them, and they've saved, in this case, 80%, 80+% on this one cluster. This is what castai does when we stack both workload right sizing and node right sizing. On the workload right sizing side of things, we do maintain a tracking of resource requests and resource utilization. So as kind of some of the previous speakers, as Yasmine had mentioned, workload right sizing is a big piece of the puzzle, but we've actually had customers that had enabled workload right sizing solutions, but because their autoscaler was not very efficient, they didn't actually save any money. They used their applications requested less resource, but they didn't save any money because the nodes were the same. They weren't able to automate the nodes because cluster autoscaler is not a very effective autoscaler. In this case, we've got the workload being right-sized. You can see that we're adjusting replicas over here, and we're adjusting the actual right-sizing of the pods. Now, this happens automatically. It's not recommendations. It's happening automatically in runtime. We're shifting right? You're setting guardrails in code, but we're actually shifting the automation to the right, and you're managing resources at runtime instead of in code. This is blowing people's minds because everybody wants everything in code, but when you actually shift over to runtime management, your developers don't know what they need for resources when they're writing code, and then 3 months later they actually deliver it to a production environment. They're just guessing, right? And those guesses sometimes are wildly high, and when they're wildly low, things break and they go fix them. When they're wildly high, they say, oh, it's working, and they walk away from the problem. This is why it's so important to right-size the workloads. Lastly, when I was talking about different instance type selections, this is an AWS account. You can see here, there's about 40 different instance types in this cluster. We have one node template. You don't have to create node groups. You don't have to create different things. I've got 17 seconds left, 12 seconds left. Oh, your clock is faster. So this i3 Metal is a very expensive on-demand machine. It's being chosen because it's a very inexpensive spot instance machine. This is the power of Cast AI. Ready, time.
Thank you so much. Thank you so much, both of you, all of you, really. Matt Ray had a minor family emergency and jumped away. So if he can, he'll come back. We'll see. Family first. Thank you so much, y'all, for presenting. Victor, the first question is one for you, actually. Well, us.
For me?
For us. Which is, it's more of a statement than a question. But Carpenter should be in there.
Yes, it's realistic. So it's hard to put things into different categories, right?
What is Carpenter?
Carpenter is for scaling stuff, right?
Okay.
And we will have a separate season on running things at scale, right? With cluster scalers, with pod scalers, with networking that works in multiple clusters and so on and so forth, right? So Carpenter could be in both, right? Because it is using metrics to make decisions, but it also is related to scale. Anyways, not in this season, but it's coming.
Okay. So those of y'all in chat, if you have questions, please do ask them. If you don't, I always have questions. And my first one is, so Phil was giving an example of like, oh, look at this cluster. It's 95% utilization, which is awesome. But my question for both of you is, if you're running at that kind of margin, what happens if you have a huge traffic spike? Like, do you have a while where that traffic can't be served? Like, does it take a long time for your tool to detect and scale? What happens if you're running with such thin margins when all of a sudden your product was mentioned during the Super Bowl and you have more traffic than you know what to do with? Yasmine, let's start with you.
Sure. So we actually typically see people want to have utilization a little bit lower than 95%, just especially for that. Say you have a big event that you know that's coming up, or you don't. You want the HPA to be able to scale and give you the amount of replicas that you need. You mentioned Carpenter, and Phil kind of mentioned that workload right sizing is just a piece of the story. We kind of look at us as how you use the pod right sizing with tools like Carpenter to allow you to scale up. I think if you're using Carpenter, there's some statistic out there that I won't remember, but it can help you scale up in like 1/10 of the time of other tools. So it kind of allows you to be really efficient, but make sure that you're scaling up quickly to handle things like that.
Right on. And Phil, what's your response to the
Sure.
same question?
Yeah, so we've done obviously we're very familiar with Carpenter. It's a head-to-head competitor with us, it's from the open source side of things. Carpenter and Cast AI can scale up a node in about 45 to 50 seconds on AWS. So fairly quick response time, and how you handle that lag in that 45 to 50 seconds, use Kubernetes tools, right? And so as your HPA scales up, you need additional capacity. You use placeholder pods. And this is a very common thing that we work with our customers on. Put out 10 CPU worth of pods, maybe half CPU pods, right? So you got 20 pods, you set them to a negative priority class, and then as your HPA scales up your critical workloads, they actually evict those placeholder pods and kick them off of the nodes. Your pods take their place, they come up to running immediately and start taking traffic. Those placeholder pods become unscheduled, and then Cast AI would then add additional capacity in that 45 to 50 seconds and schedule those placeholder pods. That gives you a riding wave out in front of the capacity you actually need and a very predictable amount of overhead, so that you don't need to run some, we typically only run 30%, 60%, 70% capacity. This gives you a very solid amount of over provisioning to hit those very hot, fast spikes.
Right on. You said a couple of things. Placeholder pods isn't a concept I've heard before. And also you said shifting right, which I thought was funny after so much shifting left talk, but I'm here for it. I would like to hear about, so both of these tools seem like it's deep in your clusters, it's deep in your estate, it's touching a lot of different resources. So that gives me a couple of questions. And one of them is it difficult to install and learn to use? So Yasmine, we'll start with you.
Sure. Our tool installs with just a Helm chart. We want to make it very simple because tools like this should be boring. You shouldn't have to think about it. So it's just, if you do it via the UI, you copy paste the commands, deploy the Helm chart, and then the tool starts collecting data. As far as learning it, if you have to learn a tool to use it, then the tool has kind of failed. You should be able to see very easily, okay, what do I need to do? What are the actions? So I'd say
Kubernetes is a huge failure then.
Totally. And we, I think, try and kind of combat that, because if you're a platform engineer, your life is, okay, I'm trying to figure out Kubernetes. This is my day in, day out. Everyone I talk to just doing user research, that sort of thing, they're struggling. And so we don't want to be one more tool that you have to struggle with. It should just work, especially given your day job.
Excellent. And how about Phil with castai?
Yeah, very similar. So everything that we support can be provisioned through Terraform. So everything, all of our components are provisioned through Terraform. We have actually one of the most downloaded Terraform providers of all AI companies in HashiCorp. So we get to have that little badge. HashiCorp is a good friend of ours. And from a configuration and setup standpoint, I showed that graph, right? Over the course of 3 days, 3 meetings, we saved a customer, 85-ish% on their bill, and that's how quickly castai can be set up. We've had customers where it was 1 meeting, 1 hour, and they installed everything, got it up and running, tuned everything, and saved 60, 70, 80% on their cluster without sacrificing reliability. The biggest part of my job and our roles in general is spreading best practices around Kubernetes, because Whitney, to your exact point, Kubernetes is a monster. It is infinitely configurable, and everybody has a different idea of what they think is best, and we run into, I would say, 9 times out of 10 ones that are bad. So we're trying to coach people on how to be resilient as well as cost effective, because sometimes those are at odds with each other with certain Kubernetes configuration parameters.
All right. So we have one question from the audience from Anton, and I'm going to start with you, Phil, this time.
Sure.
What happens if we use Argo CD? So how do we avoid issues with syncing Argo CD if requests and limits are set in the Helm charts?
Sure. So because castai is working at the pod level, at the child level, and not the deployment level, we are applying via mutating webhook on the pods. So your deployment stays in sync with Argo CD. We don't actually adjust that, so you never have any sync issues. You don't have to turn off syncing or mess with your Argo CD settings because we're acting at a different level than what your deployments are at. So we work with Argo CD all day, every day. I would say probably 60 to 70% of our customers use Argo CD.
Cool. And how about for you, Yasmine?
Yeah, I mean, that stat is the same that we see, 67% on Argo. If they're not, then they're on Flux. We give people flexibility. So one approach is you can use the webhook. The other approach is you can ignore diffs in Argo, and our applier will just make sure that we're reconciling the differences. So if we deploy a recommendation, something happens that drifts, then we will go out and proactively redeploy that recommendation. And it comes down to user's choice, whichever one that they would prefer to use.
Excellent. And then we're running short on time, so this will be the last question, and then we'll do closing statements. But I'd like to hear from Yasmine first. What's a use case where your tool especially shines, and what's a use case that where it's difficult to have StormForge come in?
Yeah, great question. So I'd say where we shine is just working with, for example, open source tools like the HPA, like Kada, like Carpenter. Our machine learning is built to monitor that scaling behavior and set both of those when we give those recommendations. That's probably our biggest because we're machine learning led. That's our strong suit. And then from where we're weaker, we are resource optimization. We focus more on going out and automatically deploying the changes. So our cost reporting, we work with partners like KubeCost. So I know Matt dropped, but they're a huge partner of ours. And so you can kind of have your costs in tools like KubeCost, or CloudBolt is another partner of ours. And then do the resource optimization, have that be the engine that is StormForge. So I'd say probably that's one of the weaker areas as you look across us in like OpenCost, for example.
Great, thank you. And Phil, same question for you, please.
Sure. I would say probably our strongest area is highly dynamic clusters. We run a lot of customers that have very cyclical workloads or very spiky workloads. Some that are running, Spark CD or Spark workloads. They're very heavy load. We tend to be able to save more money on those workloads because they are more dynamic and there's a lot more movement in there. Where we're weaker is, I ran into one customer that was running Cassandra as a daemon set. Basically, every node had its own Cassandra replica, and if you trashed that node, you lost data. There was nothing we could do there. That was probably the worst case. So, environments that are set up like very old school data center driven mentality, it's hard because if you're embracing cloud native, things need to be somewhat mobile. We could tolerate some static stuff, but when the entire cluster is 100% locked because of something like that, nobody can do anything, right? It doesn't matter, what you change the resources to, you're still going to be paying for it.
Right on. So let's say goodbye. And with closing statements, Phil, why should we vote for castai?
Sure. Castai is a great full stack solution, right? We're handling all the way from the node level, infrastructure level, through the workload level, and also providing the cost reporting. I didn't touch on the cost reporting because it is kind of a copy of what we had already seen from OpenCost. It's similar data. So the fact that we have the full suite, we're able to save a significant amount more money, as well as being able to manage the resources. So we've had really good luck with that, full stack of automation, and it's fully automated, right? It takes a lot of work, a lot of toil off the DevOps team's hands.
Thank you, Phil. Goodbye.
Thank you.
And Yasmine, why should we vote for StormForge?
Yeah, StormForge works alongside the open source tools you have. So you're using OpenCost, you're using Carpenter. We work really well with those tools. And our goal is to make sure that we just work in your Kubernetes environments, whatever tooling that you have in place, and you spend as little time. So if you want to get a quick ROI within a couple of days, have recommendations that are automatically deployed to start saving you real dollars, go ahead and try StormForge.
Awesome. Thank you so much. Appreciate you. And what should we say about, Matt Ray's officially gone, about OpenCost? It's a good one too, and it's fully open source. Yeah? Victor, I think you're muted.
I am muted. Now I'm not. Yeah, OpenCost is the base on top of which quite a few other tools, not necessarily those that all those that we talked about, but tools that are using, right, and building on top, right? And there is always, that dilemma: should we build from scratch? Should we build on top but have less control, and so on and so forth? But OpenCost, without entering into the debate how good or bad it is a very important addition to CNCF.
Absolutely. So please vote in our poll that'll go live in 3 minutes. It's in the CNCF Slack workspace in the You Choose channel. And then meanwhile, did I freeze?
Yes,
Look
you
at
did.
me, I'm frozen.
But we can hear you.
It's a nice
we can hear you.
face.
That's fine.
Yeah.
There you go.
So meanwhile,
Now you cannot. The nickname "Laughing Lady." Now this stays.
You don't need. I'll never be live on this show again. So the last thing to say is that please join us next week where we'll demo the chosen tool, and we will talk about service mesh. We'll bring in a lot of service mesh, all 4 of the major ones: Kuma, Istio, Linkerd, and Cilium, all to talk about observability at the service mesh layer. So I think that's a wrap, Victor. Imagine me waving goodbye. I'll see you next week. Bye.
See you all. Cheers.